Now, I want to begin on joins. So in the previous class, when we were doing the practical, we must have started and we did a few practicals on joins, which was the last practical I left you in class to undertake. So it's just good to appreciate an overview of these joins. So as it is, when you talk about a join, it means combination. In general, when you talk about any join, we are talking about a combination. So when you talk about DBMS joins, the key aspect about any DBMS at a very low level representation is we talk about tables, the unique attributes that makes a table. When I say a table, I mean a column. Remember that from the beginning of DB database, you agreed that a table would be represented by a column, and each of these tables has unique attributes, so that I can have a table for ID, a table for age, a table for address, a table for salary, like that. So these joins are implemented actually on tables, just a basic understanding. So we are taking a scenario that you have a Cartesian of a product of two relations. When I say Cartesian product, I mean a combination actually. As you know what is a product, so you need to combine the two relations. So which gives us possible tuples that can be paired together. So through this Cartesian product of two relations, it can give us the possible tuples that can be paired. It might not be feasible in certain cases to take Cartesian product, or it is not possible to compare the two tables or to pair the two tables in that regard, especially when you have very huge relations. I know when I talk about relation at this stage, you understand a relation is a table. A table is a relation, but a table is a column. So when I say it's not feasible for us in certain cases to take a Cartesian product when we have huge relations or when we have very many tables, or certain relations which spans up thousands of tuples, having considerable large number of attributes. Sometimes it might be difficult. Now, what is a join? A join is a combination of Cartesian product followed by a selection process. And remember, I say Cartesian product of two relations gives us possible tables that can be paired together. A Cartesian product of two relations gives us possible tables that can be paired. That is, the individual columns that can be paired. So a join is a combination of Cartesian product followed by a selection process. Remember, you will still be using the select statement when you are doing joins. So a join operation pairs two tables, as we have agreed. It's all about pairing these tables, or what we say columns, from different relations, which we have said, from different tables, if and only if a given join condition is satisfied. So you will be realizing that we have different types of joins being brought about by the different conditions that bring about that particular join. That is why I am saying if and only if, get the two statements, if and only if a given join condition is satisfied. So as soon as a given join condition is satisfied, then a join operation can pair the two tables from the different relations. So we want to distinguish between a theta join, the equijoin, the natural join. We have also outer joins. Outer joins include left outer join, right outer join, full outer join. That is it. So that's what we want to talk about. Now, to begin with, and I want you to get it. Once you get it at the inception, it's good. You can roll back easily to the others once you understand the first one clearly. So a theta join combines tables, and I say tables means columns in a relation or in a database table. So a theta join combines tables from different relations, provided they satisfy the theta condition. So the theta join is denoted by symbol. I hope you can see this symbol that denotes the theta join. Now, this is a notation. For example, I have relation 1 and relation 2. To represent a join, remember I said a theta join is this. So once you see this particular sign, it means a theta join. So when you want to talk about a join, you use this diagram. I hope you have seen this notation. There's a notation there, and you put in that theta join so that it represents that we are joining relation 1 and relation 2. Now, theta join, R1 and R2 are relations having attributes. Taking an example of R1, which is relation 1 or table 1 in that regard, having the attributes A1, A2, AN. It could be ID, for example, A1 is ID, A2 is age, up to whatever attributes that can be represented in that particular table or relation. Kindly mute if you are in class, please, so that you don't interfere. R2 as attributes, maybe ID again, customer ID, customer age, and salary, like that. So we have relation 1 and relation 2 having, for example, relation 1 as A1, A2, relation 2 as B1, B2, such that the attributes don't have anything in common. Can you get this? Theta join happens when there is no attributes in common. That is, you talk about combination of R1 and R2, and there is no relationship. Can you see how it has been represented? That is combining R1 and R2, and there is no relationship. Then it means that is a theta join. Any attribute, so that each of these columns are independent. There is a real example here. You can see in this student relation, this is relation 1, student, relation 2, subject. In this relation 1, student, it has unique attributes. These are the tables. Table SID, table name, table standard. In this other relation subject, we have table class and table subject. You can agree with me that these tables in student relation is not similar to tables in subject relation. We can agree with that. You can see that they are very unique. So theta join, as we